So just so you know what's going on today, I'm giving this presentation to all of you live. We are also doing this live on Facebook. We're face streaming or something like that. Whatever faces are involved, that's all going on right there. So no matter what, I'm going to stop talking by 9 o'clock here. Even if I've got a lot more to say, we'll cut it all short, because we're going to get out into the Oak Grove so that we can all see the eclipse in time, okay? About 9:05 is when the things will start. Anything interesting will go on. So starting at about 9:05, we will see something. Some of you will be like, oh, I see it, it's right there. I totally see this little notch taken out of there. So, that's the time to start looking for it. It won't be really until approximately 10, 17, and 48 seconds, 0.23 seconds, that we will have totality starting, okay? And then that'll last about 55 seconds, and then but the moon still has to move out of the way, so that'll take about an hour, so you're welcome to stick around and experience all that. You can do whatever you need to do. So this is our plan for today, okay? Great, so first of all, I want to talk about safety. We do want to make sure that hopefully everybody has gotten some sort of glasses, not necessarily these, but in case we ran out of these, I don't know. But if there are still more of those, you can grab those around. You will need to be wearing those glasses. Anytime you want to look up at the sun, you need to be wearing safety glasses like that, okay? You should not look directly, at any time, you should never look directly at the sun. But normally, like if you go out there right now and try to stare at the sun, your eyes will start watering, you're going to be squinting, your body will be telling you, no, this is a really dumb idea, don't look at the sun. But when the eclipse starts, it's going to get a little bit darker, and then your body won't have the same stimuli and be like, yeah, no, this is dumb, you should. And so that's why it's not safe to look at the sun during the eclipse. It's because your body won't have the same, you won't be squinting, you won't be having the same reactions going on. And so that's why everyone is saying to be very careful, be sure to wear the glasses. Now, when we have totality, when the sun is completely blocked out, we can remove the glasses for about 55 seconds, okay? At that time, Chris Geiser over here, he and I will be out there with microphones, we'll be talking to people. He has the magic whistle, okay? We will blow a whistle, and it will sound like that. When you hear the magic whistle, then you can take off your glasses, you can experience everything. It's going to be amazing. It's going to be a great experience. We actually do have a telescope that will be set up out there. We have some sun filters on the telescope that allow us to look at the sun. And so if you want to take turns and kind of peek through that, you're more than welcome to do so. We'll have that set up. We'll give you directions to how to get to that. And apparently you also, if you're going to use a camera or something like that, you should put a filter in front of that, because you can also damage the optics, again, except for when we have totality. So just some safety things with that. Okay, so what to expect. The first 45 minutes or so, not a lot is going to happen. You're going to be able to see, if you look directly at the sun, you'll see this notch getting progressively bigger, eating out of the sun. But it won't get noticeably darker, until probably about 10 o'clock or so. At about that time, you should really start looking for shadows, especially underneath trees. You'll see a lot of little crescents showing up in and around there. So that's something to look forward to. The temperature should also drop because we won't have the sun shining, so it's going to cool down quite a bit. And the wind should also pick up, okay? Now, in addition to that, we should have, by about 10:15, it's going to be very, very dark. Getting ready for the total eclipse happening. But don't take off your glasses yet, okay? Don't wait until you get the magic whistle. That will be the magic signal to take off the glasses. We will be looking, though, for, at the very end, right before the moon completely blocks the sun, there are something called Bailey's beads. Basically what this is you'll see, it looks like sort of little twinkles disappearing like that. And the reason this happens is because the moon is not a perfect sphere. It has a lot of craters in it, it has some valleys, some mountains, and things like that. And so as the mountains start covering it up, it'll block out some of the light, but then these are where some valleys in the profile of the moon exists. And so we'll be looking for that. Once we have only 1 or 2 of those left, we will blow the whistle and we will take off the glasses and just experience the whole thing. It's going to be awesome. Okay? Okay, so when it is safe, we will remove the glasses. At that time, some things we'll be looking for. Number one, all the time the sun isn't just this static thing. It's actually very alive and active all the time. In fact, the surface of it has a lot of what are called solar flares and solar prominences, things that are going to be shooting off the sun, some of them falling back in. It's really a cool show. When the moon actually blocks the sun, it will be dark enough that we can actually see some of these little red bursts coming out of the side. So that's the first thing you're going to be looking for. Also look for the corona, which will be sort of this pale halo all the way around the shape of the moon. And so that's also something to look for. We'll only be able to see either of these things for about 55 seconds though. Alright, so one thing to just keep in mind, just experience it. It's only a minute long, right? So if you've never used your camera before, except for to take like family photos, you may want to just leave that aside and just watch. Take the picture in your brain, just etch it in your brain for eternity. You're not going to, unless you really know what you're doing, you're not going to get a good picture of this anyway. Also, I've tried to take pictures of the moon with my cell phone, and you just get this little dot in there. It will not look out. It will not look like what you think it will look like. Okay, so just experience it because it's gonna go by fast, but it's gonna be very cool. Okay. Now in McMinnville, by the way, so here's the band of totality, and we're up near the edge of that. This is actually very cool for us because if we were actually closer to the blue band, we would see the solar flares and the prominences only for a short time. But being up where we are, we should actually see these happening throughout the entire eclipse. And so that's something that you can tell your friends who drove in traffic for an extra 5 to 10 hours, whatever it was. We got something that they didn't get to see. So that'd be nice, yeah. Now also, some of you may notice, not all of you will notice this, but sometimes some people will notice that every now and then I get a little bit terrified, and then I see the look in your eyes. Now for others though, that's for so many people. Now, if you do notice any of those things, though, you're looking at the wrong part of the eclipse. So, just be aware of that. That's not. And by the way, I just want to make 2 comments. Number one, some of you may have thought that was a crap joke, but it was totally worth it. And number 2, I had not seen this video in decades, and so I put it on YouTube last night. Where's Jeffrey? I saw Jeffrey. This will be your new favorite thing. You gotta look this up, I swear. There are people with glowing eyes, and one of them flies, and it's just, you gotta watch it. You gotta see it. Okay, so I'm a physicist, I'm a scientist, so it's not just interesting to me to see all these events that are going to be happening. What I actually really care about are why these things happen. And so I picked 3 of the things that we'll notice, and I just want to spend a few more moments to talk about them and kind of get across why these events are going to be going on. So why do the shadows become sharper? Why are the shadows going to become sharper and seeing all these different things? Notice that normally when the sun is shining, the sun actually has a finite size to it. It looks like a pretty small dot, but there is a finite size to that. And so when it's making a shadow, the lines from some parts of the sun are going to still be lighting up over here. So we'll have a dark shadow, but then it's not a completely sharp. Like for instance, well, you all up there can see this. My shadow on the stage, I've got two different lights shining on me, and so you can see there's a dark region, and then there's also, yeah, that's only for them up there, but it's totally worth it. Now, if we, as the moon starts blocking the sun, though, we're going to have fewer and fewer of these. And so then finally, the shadows will get really, really sharp. And that's the first thing to look for, is that it's going to be a very sharp shadow. And so you should notice that as you're, just look at your own shadow and you'll see that when we're standing out there. Also, by the way, we're going to have some pinhole cameras outside. We're also going to have some pinhole viewers outside projected onto a little sheet. And so we'll be able to see even the crescent shape projected through those. Also pay attention to underneath the trees. The reason that we see the crescents happening in the trees is the same thing with the pinhole cameras, is that basically just a little shaft of light will make it through all the different leaves and make it down to the ground, and so then we'll see a similar effect with all that happening, with all that. So that's something definitely to look for, very exciting. So the wind is also going to pick up, and so this is something to pay attention to and try to see. The reason we'll do that is because without the sunshine, it's going to get colder in our region than it is just north or south of us, okay? Because the sun is still shining over there. Now, when that happens, we've got a temperature gradient. We've got hot, cold, and hot. And when that happens, we'll get what's basically the sea breeze effect. So how many of you have ever been to the coast? Yeah, okay, good. Now, if you notice, when you're there in the morning, what direction is the breeze blowing? On shore. It's blowing on shore, yeah. And the reason it's doing that is because on shore, the land is warming up faster than the water is, right? And so then this air is getting less dense, and so then the more dense air from the sea is going to try to fill that in and pack it in again. And so then you get a breeze from the water into the shore. The reverse thing happens actually at night. When the land cools down faster and the water is still kind of warm, we'll actually get a breeze blowing out to the sea. Okay? So the same thing is going to happen today with actually, can we go back? Yeah, perfect. The same thing will happen here. Because we've got the temperature gradient, this will be more dense air than just north of us. And so the breeze should actually pick up, and I'm guessing it's going to be going somewhat northerly, maybe northeasterly, the direction of the wind. So that's something to pay attention to. And I did that reverse because when you say wind, you say the reverse, whatever it was. But whatever it was, we all understand what I mean. Okay. So the last thing that I want to go through is to talk about why are solar eclipses rare. Okay? And because in fact, the last total solar eclipse that has happened in the continental United States happened in 1979. All right, so this is one reason that people are so excited about this, is that eclipses happen a lot all over the globe, but in any one particular spot, it's a fairly rare thing. And so I think we should actually talk about this. So first question I want to ask is, when is the best time to look at the moon? When do you try to see the moon?
At night.
Generally at night, yeah. Everybody says at night, yeah. Turns out the moon is only up at night about half the time, half the month, right? The other time, like for instance, right now, the moon is up in the middle of the day, right? So that's something to pay attention to. All these different phases of the moon happen because of the placement of the moon, relative to the sun and relative to the earth. And we have all these different angles that we're going to go. And so actually, what I want to do right now, I'm going to get 3 volunteers. Could I get maybe someone who wants to be the earth, someone who wants to be the moon, and someone who can be the sun for me? You were fast. You get to be, what would you like to be? Earth, moon, or sun? Earth, earth. So, the earth, as the earth, you get to wear the GoPro. Okay, and so we'll let that continue to work. So I need another volunteer who can be my moon. Kelsey. For a young lady there who I don't know, and is not in the audience. Do you want to be the sunshine or moon? You can be the sunshine. Awesome. Okay, so your job is going to be here. We've got a spotlight here. When I get the moon up here, you will be shining the light on the moon the whole time. And I need one more volunteer. I see you, but unfortunately I need someone a little taller. I'm sorry. Seahawks. Okay. So this is the moon for our purposes today. Incidentally, by the way, this is actually reasonably to scale. If his head is about the size of the Earth, that tennis ball is the size of what the moon would be. So we can get some relative sizes. Now, if we were to do this for real, the moon would have to be way over here, orbiting around. But we're not going to do everything to scale, okay? And also the sun would be, she'd have to be in Lafayette, I think. So we're not going to deal with that either. So what we need to do here is, I'm going to put that away. If you could, actually for demonstrative purposes first, we're going to use your head, because that'll be fun, okay? If you could, now, Kelsey, if you could just stand right over here. Okay, and so what you're going to do, sir, is you are going to orbit around the Earth, and Kelsey is going to keep but very slowly, because Earth has to keep, your job now is you're going to look at his face the entire time. All right, and let's stop here because there's a little bit of a delay. So we want to get the features going on here. Oh. It's totally frozen. Oh, we lost the Wi-Fi. No, it says it's fine.
Hey Dan, can you juggle two more?
Yeah, unfortunately, yeah. You broke the camera. Oh, there we go.
It fixed it.
Maybe? Yes. Good. So it's still a little jumpy, but we'll go with it. Oh, okay. Oh, I should say. All right. So looking at this gentleman's face here, you can see. Actually, why don't you face Earth the entire time? So because of, we'll just bring the light in more so we can definitely see everything shining. So we can see his entire face here, right? From the Earth, we're able to see his entire face. Yeah? Now, if we come around here to about a week later, and you're always going to keep from this angle. We're still, well, at least this angle everybody can see, we have the right side of his face is well lit up, right? But if we were to turn out all these other lights, we would not see the right side of his face at all, because there's no light there. This is how the phases of the moon happen. And so right now, we are about at a new moon, so let's come over into like this position and keep facing Earth. And so we're still shining on the back of his head. But from Earth's position, we see basically nothing. Right? If you were to take it one step to his right, now the Earth can see just a sliver. I should have done left. Let's go 2 steps left. And put your right foot in, and then check it out. So from here, we can just see his ear, but that's the only part of his head that we can actually see from the vantage point of the Earth. Right? This is why we have the different phases of the moon happening. Okay, so now let's go with this and say, we got mics on. All right, so let's go with this, and so with this, you would expect then that maybe we should have an eclipse every single month. But that's not exactly what is happening here, because we haven't paid attention to how the moon is actually orbiting around the Earth. Actually, let's just go back to the PowerPoint. We want to jump ahead. We don't want to play that song again. Okay, so we have these, and next slide. Oh, actually, no, that was the perfect slide. Go back. Yeah, that's perfect. So when we see the full moon, that's when the moon is over here, because then we're seeing, the sun is always shining and lighting up half of the moon. At any given time, it's shining on half of the moon. But then at different times, we're seeing different things. That's why where he's standing right there, we're seeing only a little sliver of his head from the vantage point of the Earth, because everything else is just not being lit up from our vantage point. Okay, so now if we go, and so this is just showing basically the same thing, that at different positions we see different phases of the moon, like that. Okay, but in reality, the moon is not just going around us in a circle like that. It is actually tilted in its orbit. And so, I forgot about that too. So, if we were on the moon, we also see the Earth going through phases. It's the exact same physics going on. Okay, and now next slide. But the orbit of the moon is not in the exact same plane as the Earth. And so, if we could use a tennis ball to do this orbit, as we're going around, we're kind of coming up and down, and up and down. No, not at all fast like that. So, we're going like that. Just like this. Okay? And so most of the time, so like the way we have it right now, this time of year, the moon is not even anywhere in position to actually block the sun at all, right? It's only at certain times. In fact, so keep going like that. In fact, it's only when the sun is in this position, or 6 months later, that it's possible for me to actually get blocked by the moon. And so there's a lot of geometry that has to come together, that only the point where this is transitioning down here can it even work out correctly. Okay, and so it doesn't happen every month. In fact, it can only happen about twice a year. There are only two, what they call seasons of eclipses, that can happen during the year. About every 11 months is when we can get this going. Yeah, we'll keep going. So about twice a year is even possible to even see an eclipse at all, somewhere on Earth. And so an eclipse will happen though, but even then it doesn't even happen because it has to be just the right time. It has to be either a full moon or a new moon to have any sort of an eclipse happen. So an eclipse does happen about every year and a half or so, but that's going to be randomly, somewhere on Earth it will happen, but it's not necessarily going to happen here. And 1979 was the last time it happened in the continental United States. But our next chance is going to be in 2024, so mark your calendars for that. People now, I think hotels now are going to be savvy enough to look ahead, and they're going to bump up their prices well before, a couple of weeks before that. All right, so just quickly before we stop, first of all, I would like to thank Sun, Moon, and Earth. And I also want to thank various people for whom none of this would have been possible today. Lots of people in the communications and marketing department Laura Davis actually scheduled this entire eclipse, so I don't think you would be here without her. So thanks to her. Kevin Curry, Scott Nelson, Travis McGuire. Agatha has been standing doing all kinds of stuff. Chris Geiser, you're going to meet him in just a second. We're going to be outside answering questions, and then we also have Baran, Lige, and Michael have been helping with other technology aspects of things. So, what we're going to do is we're going to go outside, we're going to put on our glasses to look up at the sun. When you're not looking directly up at the sun, you can take them off and talk to your neighbors and stuff like that. All right, you'll notice when you put these on that they're very dark, so you don't want to drive with them on, you don't want to walk around with them on. So Chris and I, this is Chris Geiser. We are the co-hosts of a podcast called Crisscrossing Science. Thank you.
Everybody together.
All right. So we're going to be out in the Oak Grove. So normally at this time there would be a question session. Hold your questions until we get out there. We will answer any questions that you can line up. At the same time, he and I are going to be recording a live episode of Crisscrossing Science. And so if you would like to be infamous for all posterity, you can ask us a question on the air. We'll also be pointing out some of the cool things that people will be doing, taking some measurements and things like that. Okay? So, everybody, let's get up and thank you.